Hmm. Right, so in this class, we're going to look at kinematic. And what does this deal with? This deal with bodies in motion. So if an object is moving, it would have speed or velocity, right? So we have a couple terms to get acquainted with. Does anybody know the meaning of displacement? Kira, do you know the meaning of displacement? Displacement.
Moving something from one place to another.
Right. Kira, I should probably discuss vector and scalar quantities, right? That also plays a part. So in this topic, we have vector and we have scalar quantities. Does anybody remember what a vector is from physics? I know some of you are doing physics here. In case you all can't remember, a vector is something that has direction and it has length. Sasha, you think length is a vector quantity? Here I say a vector is something that has length and direction. Has length. I'm not say length. It has magnitude and direction. Has magnitude. Sasha, if I say the phone is 5 inches long, does that indicate direction or does that just indicate size?
Size?
Yeah. So do you think size is a vector? Like if I say something is a feet long, if I say that subway is a feet long, does that have size and direction on it, or just direction or size?
Just direction, size?
Just size. So it's not a vector, it's a scalar, right? So a vector is something that has magnitude and direction. An example vec of a vector is things like displacement. Displacement is when you move an object from one place to another place. If I have an object over here, I can move the object over here. I can move the object over here. I can move the object anywhere I feasibly want. So, Sasha, you see why we're saying that is a vector? Because I'm taking an object and I'm moving it a position. So I could state the distance I move it by as well as direction. So a vector, displacement. Um, Sasha, I think time is a vector quantity. So does time have size and direction? Can we go back in time?
No, no.
No, we can't go back in time, right? So time is not a vector. So that being said, could somebody else give me another example of a vector quantity? Somebody give me an example of a vector quantity. Nicholas, you seem like you well know about this. Give me an example of a vector quantity.
Um, Momentum,
So that again?
momentum, and force something.
Yeah. So momentum. But the maths people who do maths alone might know about these. So displacement, momentum, force, all of these things are vector quantities, right? Another one is acceleration. The reason why acceleration is a vector quantity is because you can have negative acceleration and positive acceleration. What does it mean to have negative acceleration? Sasha, If I say you're accelerating, that means you're going faster or slower.
You're going faster.
So what does negative acceleration mean then?
Like you're going slower, or you're just at a stop.
No, not a stop. You're going slower, right? You're changing your speed. You're changing your speed negatively. You're lowering down your speed, right? And velocity is also a vector quantity, right? A scalar is just something that has magnitude. Example of scalar quantities are time, length, speed. Right. So I want to make something abundantly clear. They are the vector version of things. There's the scalar version and the vector version. So, Kirsten, if you could look at this, right? What would you say is the vector quantity for speed? Do you know? What is the vector quantity for speed? So speed can't be negative, right? When we talk about speed, we're talking about meters per second. What here is the vector quantity for speed?
Would it be displacement?
No, displacement is when you move an object. That don't mean that's not speed. Nah. Go through the options. Momentum, nah. Momentum is a change in force. Force is pushing something. Acceleration is when it changes speed. Velocity, what about velocity? Do you know what velocity means? Tell Kirsten, do you know what velocity means?
It's like the rate of change in speed of an object, like how fast,
Say that again.
like the change of speed in an object.
No, you're talking about acceleration. Velocity is literally speed. Velocity is speed, right? But speed with either a positive or a negative. Let me explain. If I say positive 5 meters per second, that could mean I'm moving 5 meters per second in this direction. Versus if I have negative 5 meters per second, that could mean I'm going 5 meters per second in the other direction. That's what velocity is. So velocity is speed, but with a directional component, right? So make a note about that. Yeah. So velocity is the vector of speed. All right. Cool. Nicholas, what do you think the vector for length slash distance is? If you're measuring length or distance, you use a ruler, right? So you're measuring how far something is. It don't really have anything such as negative length. So what's the vector for that?
Um, displacement.
Displacement, yes. Displacement is how far you move an object. It can either be to the left, to the right, up, down, right? So displacement is a vector quantity for distance. Right. And that's the main ones you need to know, right? And you need to know acceleration, but acceleration is just uses, right? So the main things we'll be looking at, and in maths really, is use it interchangeably. So velocity slash speed. In maths, we're going to treat it as the same thing. In hard maths and physics will be all more specific, but in hard maths, yeah, they kind of on the same level, right, guys? So velocity, speed. So if you have a graph, it'll be represented by a V, and the units will be meters per second. And the units for velocity slash speed is meters per second, or ms minus 1. You will need to know the formula for velocity or speed, right? Sasha, do you know the formula for speed or velocity? Just speed. You can tell me just speed.
No.
No? Okay. Well, um, velocity slash speed is equal to distance over time. You never see that formula in your life.
Well, I saw it, but I didn't know what it was because nobody mentioned it.
Okay, think about it. If I ask you how fast you're going, what you gonna tell me? Like if we in the car, right, and I ask you how fast we're going, what you gonna tell me? So let me just say we're on the highway. How fast should we be going?
Like, that depends on how fast I drive, and like
But just tell me
100 kilometers or like
100
120
kilometers. Tell me the full units. Like 120 kilometers per.
per hour.
So what I mean is every hour, if you're going at that speed every hour, you travel how much?
So I
One,
travel 100 kilometers um
yeah, if you're going
per,
if you're going 100 kilometers per hour, every hour you're in that car, 100 kilometer passes. Like you would have traveled that distance. So that's where the formula comes from, is distance over time. So if I say I go in at 100 kilometers per hour, that means 100 kilometers is distance over hour, which is time. You understand?
yeah.
So the formula for velocity slash speed is distance over time, or it's displacement over time. You can use it interchangeably because you all doing maths. It isn't as important, right? Right. So the symbol for this for distance slash displacement, and don't get confused, is S. So the symbol here is S. And the units, Nicholas, you're a very good physics student. What is the SI unit for distance? Anytime we're measuring length, what is the SI unit?
Because
Yeah, so the units here is meters. And let's look at acceleration now. Acceleration, the units for acceleration is represented by A. The units for that is ms meters per second squared, or ms minus 2. Those are the units. And acceleration is the change in speed and that's also equal to the change in velocity. So the change in velocity Nicholas, you doing differentiation. It should look tantalizing. Notice that it says change in speed with respect to the change in time. Seen that?
Interesting.
So in our maths, when we do in this topic, we're not gonna do it using the things we're gonna do here. We're gonna use differentiation and integration. Yeah, just saying. All right, so you can take this down. These are the main things you need to know about. You need to know about velocity, and velocity can be used interchangeably as speed in maths. Same thing for distance and what acceleration and just is. If you're interested in knowing what each means, I'll do it here. Right, so that's the definition for velocity or speed. The definition for distance slash displacement. How far an object is moved. Right, so you could copy this down. These are the basics here. So you need to know what velocity slash speed is. You need to know what distance slash displacement is. And you need to know what acceleration is. You need to know what those things are. So as soon as you all have this copy down, let me know. Am I right? All right, so Sasha, I want you to understand what acceleration is, right? If I tell you to accelerate, what do you think that means?
It needs to go faster.
It means to go faster. So you're changing what then? What are you changing there?
The speed.
Right. What's another word for speed?
Velocity.
Right. Always stick with that. Velocity. So you're changing your velocity, and would you accept, like, let me ask that question, right? Um, which car could accelerate faster? A car that could go from 0 to 90 in 10 seconds or 0 to 90 in 2 seconds? Which one could accelerate faster? 0 to 90 in 10 seconds or 0 to 90 in 2 seconds?
0 to 90 in 2 seconds.
Right. So other than speed, we're also looking at which quantity. We're looking at speed, slash velocity, and what also affects acceleration.
The distance.
Not only distance, the time. And you choose the 2 second one.
Yeah,
Why that one was good? Why that one was accelerating faster than the 10 second one?
because a shorter time.
So it changed, it speed up faster. What are you trying to say?
Yeah,
Right. So acceleration is how fast you change your velocity. That's what it is. Like how fast you change your velocity.
2 seconds.
Um, Not quite. You're correct, but you'd have to figure out the formula. So acceleration is a change in velocity. So we went from 0 to 90. So that'll be 90 all over the change in time. How much time it take we to change from 0 to 90?
2 seconds.
Right. So that'll be 90 over 2, right? So that'll be 45 per second. So every second, I was increasing my speed by 45. Let me show you how that makes sense. If I go in, if I take in 2 seconds to go from 0 to 90, that would just say meters per second. And in 1 second, I would have increased my speed by 45.
Yeah,
And in the next second, it'll be 45 again. Always 45 and 45.
90.
90. Yeah. Right? Cool. So I think I understand the concept there. Sasha, we're going over Healy. Mr. Healy,
I don't
talk on
know.
thing.
Aliet did message on the chat, but I don't know about Healy.
Uh, Kira, what's good? So if you understand everything, this should be like physics. Shouldn't be anything that new.
Yeah, good.
Okay, cool. Nicholas, easy stuff.
Yeah.
All right, nice. Love to hear it. Kirsten, what about you? I want to know how you going.
Second reader.
How are you going? Are these things you're familiar with? Are you familiar with these things?
Yeah.
Okay, cool. All right, so copy this down and I'll give out some questions so we could apply this. Right, so as soon as I have this copy down, just let me know, right?
Finished.
All right. What's about the others? Nicholas, we can see it, which is a good thing.
Finish.
All right, good. The rest of you all, everything on the screen. I gotta copy down everything on the screen.
I finished.
Okay, nice. So is everybody more or less finished? Kirsten, you let me know what's going on.
Yeah, I finished writing.
Okay, so let me look at some really, really simple questions before we move on to graphs, right? By the way, in this topic, you'll have two different types of graphs, right? You'll have two different types of graphs. Nicholas, you want to tell everybody the type of graphs you could have?
Velocity and distance. Well, velocity, time graph, and
That's it. So
time graph.
in math, there are two types of scenarios. And the two scenarios are you would either have a displacement time graph, you would either have that, or you would have a velocity slash speed, because we know velocity and speed mean the same thing in maths. In maths, we treat it as the same thing, right? But we know it's not actually the same thing. Speed. So these are the two graphs you will have to look at. So you can just copy this down quickly. But before we move on, before we move to these graphs, I think I need to understand the formulas and things a little better. So copy that down quickly. In math, there are two types of scenarios: displacement time graph and velocity speed time graph. Copy that down, guys. Right. Right. So I presume that everybody copied down already. So now much copy down displacement time graph and velocity speed time graph. Let's look at some simple questions now. All right, so question one. So Sasha, when you help me with this, right? So they're saying that a car is moving at a constant speed of 20 meters per second. How far does it travel in 10 seconds. Actually, I'm gonna change that in okay, so can I add a trick here? Well, Sasha, give this question already.
A car is moving at a constant speed of 20, listen,
Meters, meters per second.
20 meters per second. How far does it travel in 1 minute? I can't see because I use my phone.
Oh, okay, okay. So let me try to understand what's going on. Did they give us the speed or the velocity? Did they give us that?
No, they didn't give us the speed. Well, oh yes, they did actually. 1 minute.
Wait, what? Whoa, whoa. Kind of scared, muddy. Read back the question. Look for speed. Speed. Remember, speed is how far you move per time. Look at that.
Oh, my bad. 20 is the speed.
20 what?
20 meters
Don't just say meters. Meter.
per second.
Right. So every second, how much? If you're moving at that speed, if every second that passes, how far do you travel? It's 20 meters per second. What does that mean?
It means you're moving 20 meters every second pass.
Yes. So how much seconds does it have in our minutes?
60.
So if you travel for 60 seconds and every second you just travel 20 meters, how would you figure out how much you travel?
Um,
Try to figure that
just
out.
multiply.
Just multiply, correct. So that's the intuitive approach. So let me look at it from the intuitive approach. And I'll also show you all using the formula. They'll want to see you use the formula, right? So Sasha, stay focused. So the speed, they gave us the speed. The speed is 20 meters per second, right? And Sasha, what does that mean? What does 20 meters per second mean? This means, tell me, Sasha, Sasha,
All right, here.
what does 20 meters per second mean? This means, what does it mean about the journey of the car? This means
Gone.
the car travels. How much does a car travel every second?
20 meters per
So this
second.
means the car travels 20 meters every second. Because then we can understand that, right? 20 meters per second. So every second that you drive, you would have traveled 20 meters because it's 20 meters per 1 second. Kirsten, is that clear? Does that make sense?
Yes.
So Kirsten, if you drive at that speed, so every second you drive 20 meters pass. How long you drive on your road for in this question? So Kirsten, in this question, how long did you drive for? Could somebody tell me how long the person drove for in this question?
1 minute.
Yeah. How far does it travel in 1 minute? So the person was on the road for 1 minute. So the time is 1 minute. Now we're working in meters per second. So let this be a lesson. If you see in meters per second, you have to convert the time to seconds, right? So 1 minute is actually how much seconds, Sasha? 1 minute is actually how much seconds?
60 seconds.
So now it's very easy. If you want to figure out the distance would just be equal to what?
20 times 60.
Yeah. Well, it's 20 times 60. And I want to include the units, right? So 20 meters per second, that's meter per second, multiply by 60 seconds. Now, notice what's going to happen. The S and the S will cancel off, and I'll end up with 20 m by 60. So what is 20 by 60, Sasha?
1,200.
Yeah, 1,200. And what's the units? What's the units for distance?
Meters.
Yeah, watch, because the second and the second will cancel off, and it will leave us with meter. So it's 1,200 meter, 1,200 meters, right? That's the intuitive approach. And we understand that. Sasha, any exam, you think you could figure this out? If you see 20 meters per second, you know every second is 20 meters. You travel 60, 60 by 20, bam. You get the answer. So you okay with this?
Yeah.
This is the intuitive approach. And if we strictly use any formulas, then, well, they might understand a little bit less, but the formulas come from this. This is the common sense approach. And you will get full marks. Let's look at it from a equation perspective. Let's look at it from that standpoint. Sasha, do you remember it's having an equation for speed? Do you remember there being an equation for speed? Speed is equal to what? Does anybody remember an equation for speed?
Is it the distance over time?
Right, speed is distance over time. Now, if I write in the symbols, what symbol do we use for speed? Kirsten, what symbol do we use for speed? Do we use S, V, T? What do I use? What do I use for speed slash velocity? What symbol?
P.
S, V. You said V?
Yeah.
Yeah, that's correct. What do we use to represent distance? Remember, distance and displacement is the same thing. And I use, what would I use? Is it V, S, or T? Nicholas. Oh, Kirsten, I see you on mute. Tell them.
LVD.
You said T?
D.
D?
Yeah.
You're not wrong, but let me use S in this case because we're moving away from the scalar quantities. We're treating distance as if it was displacement, right? And the symbol for displacement is S. We're not wrong, right? And obviously time is T, right? So Sasha, we have V is equal to S over T. What are we trying to find for in this question, Sasha? Tell me, in this question, we're trying to find for what? The
We're
speed,
trying
distance,
to
or the
find,
time. We're trying to
we're
figure out
trying
for
to
the
find the
speed,
speed.
distance. You say we're trying to find for speed?
Yeah. Wait, no.
No.
We try to find for the distance. My bad.
Correct. We're trying to find for the distance. So in the algebraic approach, you underline what you're trying to find for. So we are trying to find for S. If I want to make S the subject of the formula, what would I have to do on both sides? Guys, we in Form 5. This is like, we could do this. So Sasha, right now, S is being divided by T, but I want to get rid of the T because I want to find for S. What is the opposite of dividing by T?
Gotta multiply.
I have to multiply by T on both sides. So if I do that, the T over here will cancel off, so S will be equal to VT. Sasha, you understand?
Yep.
So according to this formula, I know it's looking like S is speed, right? But no, S is displacement slash distance. So the displacement slash the distance is equal to the velocity by the time, right? So Sasha, what was the velocity?
20 miles per second.
Meters. We don't use miles here. We're not America. We don't ever use miles, actually. We never use miles or inches in maths, right? So 20 at the time. What was the time?
1 minute.
Right, but am I going to write, am I going to put one
No,
here?
60 seconds.
Did somebody tell me why I need to put 60 seconds? Right now I have 20 meters per second, and I want to multiply that to figure out distance. Why wouldn't I multiply that by 1? Nicholas, I think you could tell us, why wouldn't I multiply the 20 by the 1 minute?
SI units a second.
Yeah, SI units are important, but the maths people probably wouldn't know about that. So we had to describe it a bit different. Sasha, is meters per second, and okay, in meters per second, what we measuring time in there? What we measuring time with over there?
Seconds.
And now we come and say minutes. Is there any way I could make minutes seconds?
Nah.
No.
Well, yes, you just
Give me a
gotta,
second.
you could, but
You don't know,
you
but
gotta multiply.
it could. That's not a problem. We had to multiply by 60. So the whole point of it is you need to have the same units throughout. You need to have the same units throughout. If it's meters per second, I need to have my time in seconds. So I would need to convert the 1 minute to seconds. So I would say 1 multiply by 60. 1, because I have 60 seconds in 1 minute. Sasha, if I had 2 minutes, how much seconds I would be?
That would be 60 by, well, 2.
Right. But anyways, we're going to end up with 20 by 60, which is 1,200. And again, the unit is meters. For anybody that confused by that, right? Look at it again. It was meters per second, and we're multiplying that by time, which is second. Can you see the S's canceling off? Thomas, Sasha, can you see the S's canceling off? I'm hearing from Sasha. Kirsten, if the S's cancel off, it will leave us with what? Meters per second is speed by time second. It would leave us with what? If these cancel off,
Just meter.
just meter, and that's how I get my distance, 1,200 meters. Right? This method is the more standard method, is the formula approach, using the formula. Right, so I want you all to take this down, and I will give you all a similar question to that. And you could use any method. Right, so copy that down. So the main formula needed to remember is speed is equal to distance over time. And using that formula, you could make anything the subject define for whatever you want. So speed is equal to distance over time. Right, so I'm going to change up this question, and you will no longer be trying to find for the distance. So a car is moving at a constant speed of 25 meters per second. Right, so as soon as you all are finished copying down question one, try this question out for now. And you could try to figure it out using the common sense approach, like the logic, or the formula approach, whichever one works for you. Right, so as soon as you guys have all of this copy down, I want you all to move on to question two. Right? Kira, you've been awfully quiet. How are things?
Good.
Are you sick as well?
I don't know. I think I got it. I feel the sore throat coming.
Yeah, yeah, you sound kind of sick. Wouldn't lie. Sound like you're real tired. Um, so Kira, did you copy down the different ways of working? You have all the working copy down?
Yeah.
All right, try part two now. Nicholas, I think you could look around and get the answer. And is that possible? Can you look around and
Yeah,
get it?
yeah.
Yeah. Sasha, tell me if you understand any logic behind the question. That's the main thing, and you have to understand what the hell you're doing. Like you can't just I notice you're reading the question, but being absorbed,
Yeah,
you gotta absorb it. You gotta be like SpongeBob.
nah, I just kind of zoned out. You got right time, but I understand how to get the answer.
So you get the answer?
Well, I almost finished it.
Okay. Kirsten, what about you?
Oh, that's it.
Kirsten, are you trying part two?
Yeah, I write it down. Write it down.
Okay. Did you start working on it?
No, I'll write it down the question.
All right. I want you to help me with this question, part two.
I got the answer.
Okay, cool. Somebody working. I need to see the working. I need to see your logic. What did you do?
My logic might be similar to the first one, but not the exact same thing, yeah.
No, it wouldn't be the exact same thing because in this one you're not finding for
For
distance.
distance, for time.
Yeah, you're
But
finding
like
for
what I
time. So it'd
mean,
be different.
it like it's completely like different.
Hmm.
Yeah. I sent you my answer.
Yeah, that's correct. That's correct. But we need to put a little more work in though. To put a little more work in.
Yeah, I realized that.
So if you want to do that, write the formula. So it looked like, so what I mean is you decided to put the distance over the speed. That's correct. Um you can see what you can see something just now. But understand what you do.
Okay.
If it moving at 25 meters per second and it traveling 500 meters, then obviously you go divide to figure out how much time it take. That ain't really
I
that hard.
feel I feel like this is like basically just multiplication and division.
More or less. Yeah. Kirsten, you ready? I mean, if you're ready, Kirsten.
Yeah, I think,
All right. So, Kirsten, how did you do it? Did you do the common sense approach, like the logic,
yeah,
or you do the
yes.
formula?
I rearrange it and put the distance divided by this.
All right. So, the original formula that you would have had was phi is equal to s over t, right?
Yeah,
And then you made what the subject of the formula?
I have 500 over 25.
Say that again.
I had 500 over 25 and I get 30 once. So I go out to part.
Wait, you're breaking up plenty. Yeah, Kirsten, you were saying you made what the subject of the formula here? What did you make the subject? Uh, Kirsten, I see your mute.
They can hear me now.
Yeah, I can hear you now. So what did you make the subject of the formula?
Um, I, what I for the subject, I just write.
What you make?
I didn't make anything in the subject in no weekend. I just like rearrange and put the distance.
Oh, um, so that's the thing. You have to put the work in or like lead up to it. So you can't just put the 500 over the 25. You have to work towards it. So let me show you what we're talking about, right? So Kirsten, you there?
Yeah,
All right. So Kirsten, V is equal to S over T. We need to make what the subject of the formula here. What are we trying to find for here? What are we trying to find for in this question?
the amount of time it takes to cover.
Right, so we need to make time the subject of the formula. So to make time the subject of the formula, I can multiply both sides by t, right? I'll get Vt is equal to S. And then I want to find for t, so what would I have to do on both sides now?
Divide.
Divide both sides by V, that's correct. So time would be equal to the distance all over the velocity, right? So time would be equal to 500 meters all over the 25 meters per second, right? And in doing that, you'll get your answer.
So
Now,
if I don't put in the first part, I will do max for you get.
here what? You don't need to put this, right? You don't need to put that. If you remember that T is equal to S over V, just write the formula.
Okay.
But don't just jump straight to this line. Write a formula first. So, Sasha and Kirsten, I think I'll immediately jump to this line, right? Like when I look at the question, I'll see that this was the answer. let me show you what to do. To make sure they don't lose our mark, backtrack a little bit. So you are saying that T is equal to 500 over 25. So Sasha, a formula for that would be S over V, because then 500 is distance slash displacement, and
Yeah.
that symbol is S, and then 25 meters per second, and that's velocity.
Yes.
That symbol is V. So you could have figured out that the formula is T is equal to S over V. You just write it on top. You
Yeah.
understand?
Yeah.
Cool. So Kirsten, I believe the answer you're supposed to get was 20.
Yeah, 20 seconds.
20 seconds, that's correct. Nice. Right. And this part of the working here is optional. This is optional, actually. Yeah, this is the optional part of the working. Right. Cool. Nicholas, I guess you get it correct because you are Nicholas after all.
Yeah, do it mentally.
Yeah, just build different, right?
Course.
So we look at two simple questions, and we're going to ramp it up. So we dealt with questions that have speed, distance, and time in it. Let's do a question with acceleration in it, shall we? Question 3. A cyclist starts. Oh, I have a question, right? Sasha, in these questions, it said that the car was moving at a constant speed. If the car is moving at a constant speed, does the car ever accelerate? What do you think?
No.
You think no, right?
No, because they cannot going faster.
Exactly, going at a constant speed.
Yeah.
Right. Keep that in mind for when we're doing the graphs. Right, so a cyclist starts from rest and accelerates uniformly at 2 meters squared per second. It's a little bit harder. So recall the formula for acceleration, right? Let's recall the formula. So acceleration, you can think of it as a change in velocity or the velocity over time, right? So, All right, so Nicholas, I want you to give this question a read.
A cyclist starts from rest and accelerates uniformly at 2 meters squared per second. How fast is the cyclist moving after 5 seconds?
Okay, so according to 2 meters squared per second, every second that goes by, his speed increases by
2 meters squared.
no, not 2 meters squared, 2 meters, 2 meters per second. Wait, I make a mistake with the units here. My bad. It's not 2 meters squared per second, it's 2 meter per second squared. It's 2 ms minus 3. Yeah, that was kind of weird. Right. So for every second that passes by, the speed increases by 2 meters per second. So if 5 seconds pass, what speed do you think the person is starting or it would reach? Keeping in mind the cyclist started from rest.
10 meters per second.
10 meters per second, that's correct. Right? Nice. So let we understand what's going on here and how we could use the formula. So acceleration is the change in velocity over time. Now, when we talk about change in velocity, we are referring to, okay, so Sasha, in the question, they said that the cyclist starts from rest, right? If the cyclist is starting from rest, what is the initial speed? What is the initial speed the cyclist is going at the start? Come on, Sasha.
Well, at a low speed?
No, here we're saying, right? At rest. If I say you starting at rest, at the very start, would you even moving at all?
No.
No, you wouldn't even be moving. So that means our initial velocity was what?
0.
0. And from 0, we would move up to some speed. Yeah, agree?
Yeah.
Okay, cool, cool. So the change in velocity is the final minus the initial. So the change in velocity, delta V, is the final velocity minus the initial. So V is final velocity and U is initial velocity. So the full formula would actually look like A is equal to V minus U all over T. Right? So Sasha, I know it's a lot to take in, right? But remember what acceleration is. Acceleration is how fast you change in your speed. So we need to figure out how much it changes speed by, well, the velocity with respect to time. Like how much time it takes to change your velocity. You with me?
Yeah.
You sure?
Yep.
All right. So let's plug in everything we have. Right, let's plug in everything we have. In this question, what did they give us the acceleration?
Yeah. 2
Meter.
meters per second square.
Right, so they gave us the acceleration. I just gonna plug in 2 for now. 2. And do we know the final velocity? Do we know the velocity after he traveled for 5 seconds? Did they say anything about that velocity?
No.
No. So we don't know what that is. Do we know the initial velocity? That's like at the start. What speed was he moving at the start? That's all I had to say.
0.
0. And do we know the time? Do we know the time he took?
Yes.
What's the time he took?
5 seconds.
Right. So let me put everything into the formula, right? So Sasha, where's V minus zero?
0.
No.
Well,
Could somebody tell me what V minus zero is?
is V?
Yeah, it's just V. If I had $100 and I take away $0 from it, just 100,
Here.
is V over 5. And if I wanted to make V the subject of the formula, what would I have to do?
Multiply.
Or we have to multiply both sides by. So what is I want to find for V here. I only want V to be there. Right now, V is involved in something. Nicholas, you could almost say that V right now is involved in a situationship. And we need to break up that. V needs to focus on itself.
That's real crazy.
Yeah, V needs to focus on itself. Right? So Sasha, how would we make V focus on itself? It's V divided by 5 right now. What's the opposite of divide by 5? We need to get rid of the 5.
Multiply by 5.
Right. And we're doing that because divide by 5 and multiply by 5 would cancel off. And that would give us V. So V is really equal to, tell me, Sasha.
25.
No, not 25. So I multiply both sides by 5. The 5 and the 5 would have cancel off. And where's 2 by 5?
Oh, 10.
And where's the units for velocity?
V.
No, V is not the units. When I say units, I mean like meters or something.
Oh, so it would be 10 meters
Remember, velocity or speed is meters per,
per second.
right? Because speed is how far you travel in a given time. So it's always meters per second or kilometers per hour, that kind of thing, right? This was a formula approach. Now, if anybody here doing physics, they would probably know the formula V is equal to U plus AT. That formula is the same formula as this, we just derive it. But we're not doing physics. We kind of are doing physics. This is physics. But I'm trying to break it down for like a maths purpose. This was the formula approach. Kirsten, you think we could look at this logically and figure out the answer? Tell me, Kirsten, you think we could look at this question logically and figure out the answer? You think we need to do all that?
I think we can figure it out logically.
Say that again?
I think we can figure it out logically, like without all the work.
I think so too. So remind me, what does acceleration mean? If I'm saying I'm accelerating at 2 meters per second squared, what does that mean?
So what are students?
Say that again?
So what are students?
Not quite. What does accelerate mean? If I tell it to accelerate, what do I mean? What does accelerate mean?
The
Imagine you,
next one is like when the velocity of an object changes.
right. So if you're in the car and you tell your father to accelerate, you're going too slow. What do I mean? What are you telling him to do?
Like the speed up.
To speed up, right? And then speeding
Yeah.
up take some time.
Yeah.
So that's why the formula is change in velocity over time. Because to change the speed, it would take some time, right? So the person here starts at rest. So the initial velocity is 0. We know that. Okay. And for every second that passes by, they are increasing their speed by how much? Tell me, Kirsten. So they're saying the acceleration is 2 meters per second squared. So what does that mean? Every second that goes by, we are increasing our speed by?
5 seconds.
No, that don't make sense. Think about it. Asking you how much we increasing our speed by. It wouldn't be seconds. So Kirsten, let me try to explain it in a different way, right? Let me take my time. So let me just say it have a car that going from 0 to 90 meters per second, and it's taking 2 seconds. Right? So Kirsten, tell me if you with me. So
Yeah.
the car is going from 0 to 90 meters per second in 2 seconds. So in 1 second, how much is the person increasing his speed by? See if you could figure that out. So in 2 seconds, it went from 0 to 90. So how much it would have had gone in 1 second? So if in 2 seconds it went from 0 to 90, how much would the car have went in 1 second?
You have to divide the 90 by 2.
Right. Away we go.
45.
Right. So in 1 second, for every 1 second that passes, the speed is increasing by
45.
45 meters per second. Let we understand that, right? Stay with me. Let we understand that. So to figure out the acceleration, I'm going to say, well, it'll be 90 minus 0, right? Because 90 is the final, 0 is the initial, 90 all over. And let me keep the units in mind, right? You're an odd math student. Let me keep the units in mind. So the 90 and the 2 would cancel off, and you get 45. And then we look at the units now. So you have meter per second multiplied by 1 over a second. So you're going to put 45. M by 1 is M, S by S is S squared. So that's how you get the meter per second squared. So Kirsten, what acceleration means is that, so you see this thing over here? It means that every second that passes, my speed increases by 45 meters per second. That's what it means. So I'm asking that question, Kirsten. If 3 seconds pass by, what will be my speed now? If I continue to accelerate, what will be my new speed?
90.
Say that again?
90 divided by 30.
No. We already know the acceleration. According to this information, in 1 second, how fast am I going? Like in 1 second.
45 meters.
So
Yes.
in 1 second, I've increased my speed to 45 meters per second. In 2 seconds, I increased my speed to 90 meters per second. So my acceleration is 45 meters per second squared, meaning that every second I raise my speed by 45 meters per second. So if
It was 45 by 3.
45 by
3.
3, correct. Correct. And that would be what?
125.
Right. So I think you understand it there. So for every second that passes, the speed increases.
Right.
Right?
Yeah.
So in this question, the acceleration was what? We found the acceleration to be
45 meters.
right, 45 meters per second squared. And what does that mean? That means that every second, my speed increases by 45 meters per second. So that make real sense, right? So if you're okay with that.
Yeah, okay.
Cool. In this question, the acceleration is 2 meters per second squared, which really means that every second, my speed increases by
45 by.
now in this question, they gave us the acceleration already. It's 2 meters per second squared. So watch. 45 meters per second squared means that every second speed increasing by 45 meters per second. Same thing over here. 2 meters per second squared. That means that every second the speed increasing by
2 meters per second.
correct 2 meters per second. And how long did the person travel?
For 5 seconds.
For 5 seconds. So if in 1 second it increases to 2, how much should go increase in 5?
5 by 2 is 10.
That's it.
Yes,
Real simple, right?
yeah.
Yeah. Sasha, I want to explain that back again for anybody that might be confused because this is important to see it in this way. So Sasha, back to this, right? If I want to go, well, if I go in from 0 to 90 meters per second in 2 seconds, what is my acceleration? How much am I increasing my speed in 1 second?
45.
45. So my acceleration, look at this carefully, right, Sasha? My acceleration is 45 meters per second squared. Now, what does this mean? That means every 1 second, my speed increases by 45 meters per second. Is that clear?
Yeah.
So that is what acceleration means. So Sasha, over here now, it means that every 1 second that goes by, I'm increasing my speed by
By 45.
45.
Wait,
What is the acceleration in this question? What is the
2.
acceleration in 2 meters per second squared? So that means every second that goes by, my speed is increasing by,
2 meters per second squared.
no, 2 meters per second. The 2 meters per second squared means this. That's what it means. And if I were to multiply it back, watch, the second and the second will become squared. So Sasha, the 2 meters per second squared, this is what it means. Like in a practical sense, that's what it means. It means every second that goes by, my speed is increasing by 2. So, Sasha, in the first second, I start off at rest. In the first second, what would my speed now be? In the first second. Remember, I accelerated at 2 meters per second squared. So what would my speed be in the first second? Sasha, I feel like you're a little confused. Hmm. Sasha, if you're talking, you muted it. I'm Nicholas, you hearing me?
Yeah.
Sasha, I need you to get this, huh? Um, I need you to unmute. I need you to catch this. So, Nicholas, are you understanding what I'm saying? Like every second that goes by, your speed increasing by 2 meters per second. You understand that?
Yeah.
And well, if you start off at 0, then that 0 will increase to 2 meters per second, right? And since you cycle for 5 seconds, then that'll be 5 by 2 is 10. So you reach a speed at 10 meters per second. So Sasha, I go explain it one more time, right? For anybody, I will explain it one more time. I will explain what acceleration means. Acceleration is just the rate at which you change velocity. Rate at which you change velocity. And the units So, Sasha, I'm going to give you an example, right? Let me just say the example is 50 meters per second squared. What this mean? What does this mean? That means every second, my velocity is increasing by 50 meters per second. That's what it means. So let me just say I start off at rest. If I were to start off at rest and 1 second were to go by, my speed, my velocity would be equal to 50 meters per second. Let me just say you continue accelerating for 2 seconds. If you continue to accelerate, your new velocity go be what, Nicholas? If every if if 1 second, if every second you change in your velocity by 50 meters per second, and you travel and you accelerate for 2 seconds, what's your new velocity?
100 meters per second.
Yeah, that's the logic. That's the logic. That's literally it. So for every 1 second, velocity increases. So this is it. This is it. That is what acceleration is. So if we want to do it in an intuitive manner, this is what we could write. So the acceleration is 2 meters per second squared. What does that mean? That means every second, my speed, well, I should put velocity. My velocity right? So that's the answer there. This is the intuitive approach, right? So acceleration 2 meters per second squared. That means every second my velocity increases by 2 meters per second. Since we started at rest, the initial velocity is 0 meters per second. So we starting off at 0 and then we go for 5 seconds. And if we keep on accelerating for 5 seconds, then our new velocity will be 5 by that acceleration. So it'd be 10 meters per second. So Kirsten, is this crystal clear? Like, do you understand this 100%?
Yes, sir.
Nice. Nice. So I'm going to change this question, but instead we're not going to start at rest. We're not going to start at rest. Okay. Right, so I want you all to do question 4. So a cyclist starts at 10 meters per second. So like somebody could have probably pushed them and now they're going 10 meters per second at the very start. And then they start to ride faster and they keep that momentum and accelerate uniformly at 3 meters per second squared. So how fast is the cyclist moving after 3 seconds? That's the question. Try that one. If I like you get through with this one, all is like certified. Definitely not what Kendrick said. But you're all certified geniuses. Nicholas, you get that one? Get that joke?
Yeah, I catch it.
Yeah. You watch the Super Bowl halftime?
Yeah, I watch somebody I see some TikToks on.
I feeling bad for Drake, yes. Everybody just know that man for, it's
Yeah,
crazy. Right, so Nicholas, I think you could figure out 4 without using all that fancy maths. Just by just by using the intuitive approach. So Kirsten, we go run through 4 together, right? But still do it. I want y'all to do question 4. See if they could figure out the answer. Okay, so do we have answers?
yeah.
All right. Kirsten, do you have an answer?
I'm almost finished.
Okay. Okay, Kirsten, do you have an answer? All
Yeah,
right, so let's run through the question, right? So, Kirsten, first things first, right? Um, what's the acceleration on this question?
3 meters per second squared.
And we know what that means now. If I'm accelerating, so the acceleration here is 3 meters per second squared. What does that mean?
It'll be 3 by 3, which is 9.
Right? 9.
And you have to add, it'll be the 10 plus the 9, which is 19 meters.
Perfect. That's it. But I want you to understand, I want you to explain the logic for me, right? What does 3 meters squared per, what does 3 meter per second squared mean? This means every second,
It is increased by 3.
this means every second, the what's increasing, the, tell me, this means every second, the, what is increasing? The what? Can't hear properly.
3.
Type in the chat. This means every second, the what is increasing. So every second, the what is increasing? By how much? Houston. Didn't get any messages from him. Nicholas, you think you know the answer to the blanks here?
Yeah.
So when we accelerate, what is increasing?
Every second, the meters increasing by 3.
Say that again.
Every second, the meters increasing by 3.
The meter is increasing by 3. No. When we accelerate, we increase in what?
The
Think
velocity.
Speed.
the velocity. That is what we're looking for. The velocity or the speed. Right? That's what it means to accelerate. And we increasing it by what are we increasing the velocity by?
3 meters per second.
Right? Right. Right. And in this question, right, the initial velocity was 10 meters per second. So the initial velocity is equal to 10 meters per second. So what this means is the person here, they were starting off at 10 meters per second, right? They start off at 10 meters per second, and then they decide to accelerate for 3 seconds. So that would be 3 by 3, and you'd end up with 19 meters per second as the final velocity. So final velocity Yeah, that's correct, Kristen. That's correct.
I did the same thing, but just in a different way, and get 90 meters per second.
we understand, right?
Yeah,
So you accelerate for 3 seconds. So that means any first second increase by three, then the second one is six now, then the third one is nine, and they start off at 10. So you had to add it to 10, it's 90, right?
it's
Um,
American.
wait, so
I say I go in and send you the working.
all right, cool. Physics people, I look at a easy formula. V is equal to U plus AT, right? You just have to, it's already in the form there. So V would be equal to the initial velocity, which is 10, plus the acceleration 3 by 3. So Nicholas, you realize we just came up with that formula, right? That's what we do. We came up with that formula.
Yeah.
So this is the initial velocity, right? This is the time and this is the acceleration and that's the final velocity. So we come up with our formula because we just that smart. We just that go to we coming up with formulas and things. So you could also say um V is equal to U plus a T. Right. So Nicholas, you don't think that's cool? Like we come up with our formula just by logic. Like we just dab at it, you know?
Yeah, just add to
Yeah.
what this so.
Yes, Asha, that's correct. Actually, let me see what we do here. Yeah, that's correct. That's correct. Nice. Good job, Sasha. So we covered the basics of kinematics, right? Now all you understand what velocity, acceleration, displacement, and thing is. Now we could move on to the graph questions, I would say. So let me just show you what ours look like. So what does it look like? That's speed time. Okay, this is our distance time. This is easy. What's the easier one? All right, so Sasha, check this out. Check this out. Hmm. Looking hard. Sasha, honest thoughts.
Yes and no.
Well, let me see if we can do it fast now. Like I got 5 minutes. What was the average speed during the first 2 hours? So the first 2 hours, and the first 2 hours, so Sasha, in the first 2 hours, what's the distance you travel? Right? So right over here we have hours. So in the first 2 hours, how much distance you travel?
12.
Right? If I want to figure out speed, speed is just distance over time, right? And speed is distance over time.
Yes.
Yeah, speed is distance over time. So the distance here is 12, the time is 2. Well, that's real easy. The answer would just be, in this case, it could be 6 kilometers per hour. What did the athlete do between 2 and 3 hours after the start of the journey? Right? So, Sasha, this line
Speed.
indicates that the the person is running, right? Is covering some distance. So if it's just flat, what do you think he's doing? So at 12
He running
kilometers,
at he running at a consistent speed.
no. You're talking
Yeah.
about a velocity time graph. This is a distance time graph. In a distance time
Oh,
graph, this is how much. So watch. Just showing you how much distance he covering, right? So at 1 hour he cover 6. At 2 hours he cover 12, right? At 3 hours, where's he at?
12.
At 3.5 hours, where he's still there.
12.
So if time pass and he's still at the same place, what I mean? If time pass and you're in the same place, what you doing? Promise is a real simple answer. So for this time period, he just I don't want to say the answer, Sasha, tell me. You know the answer for this. At 2 hours, he was here. At 3 hours, he was here. At 3.5 hours, he was here. What he doing between 2 and 3? Yeah, 2 and 3. Sasha, is he moving?
No.
No, he not moving because watch. At 2 hours, he at the 12 kilometer mark. At 2.5 hours, he's still at the 12 kilometer mark. At 3 hours, he's still at the 12 kilometer hour mark. Is he moving?
No.
No, he not moving. He at the same place. So between 2 and 3 hours, he probably taking a break. He not moving. Right? Um, right? What was the average speed on the return journey? So let me look at this question. So this is the to journey and this is the return journey, right? So to figure out this, you need to find gradient. You need to find gradient. That wouldn't be that hard. So Sasha, imagine this is our racetrack. That's what's going on. So this is a 12 kilometer hour. I mean, this is a 12 kilometer racetrack. So you go to the finish line and then come back to the start line. You understand what I mean?
Yeah.
So to go to the finish line is 12, and to reach back to the start is also 12. You understand?
Yeah.
So we know that the distance is still 12 because it's a racetrack. To and from go with the same distance. And how long that take you? This is 3.5. This is 3.5. So between 3.5 to 5. How much time is that, Nicholas? 3.5 to 5.
1.5.
1.5, right? So 1.5. And that's the answer. 12 over 1.5. Plug that into the calculator and that is it. 5 up, 5 marks. That's it. 5 marks. That's real easy. Sasha, tell me. That easy or not?
Yeah.
Yeah, we could manage this. So next class we will do questions like this. I'll understand the basics. So thank you very much for coming to class today. Question, are you prefer classes on Wednesdays or Tuesdays? I personally, Wednesdays be kind of tough for me
We
because
do
that's
any
because I come home late and thing. So what date?
Tuesdays, anything.
Yeah, this is normal.
Kristen, would Thursday be better for you than Wednesday?
Yeah.
Okay, well, I'm just asking chat and finalize. We can move classes to Thursday, right? Physics people, I see on it tomorrow. But I don't really have any physics people here. Don't have any physics people here. But again, thanks for coming to class today, guys. I hope all you have a good night. Later.
Yeah, you too later.
Later.